Oh, hey, didn't see you there. My name is Bianca Reynoso, and I'm in Math 141, Section 4D, in the Spring 22 semester. And I'm actually going to be talking to you about invertible matrices. So the inverse of an n by n matrix is another n by n matrix defined as followed. Let's say we have matrix A. If A has an inverse, A raised to the negative 1, when these two matrices are multiplied, we'd get the identity, whether it's a 2 by 2, a 3 by 3, or a 3 by 3 again. Let's go over an example. And now for the example. Here we have A. A is just a given matrix actually taken from our professor Suzanne Cindy's notes from, I believe it was 1.3 or 1.6. I'm going to have to get back to you on that one. We're actually going to use it the Gauss-Jordan method, where we find A inverse by augmenting A with the identity matrix. And pretty much, we're going to see some magical math happen with some elementary row matrices. One of my friends is going to tell you about those, actually. But let's see some math. So here we have A augmented with the identity matrix, and we're going to do some row operations to get to where we need to be, right? So in the middle here, you can see that instead of having just the identity matrix or just A on each side, we kind of have a mix of both. We can see where the remnants of the identity matrix is here, and we can see some remnants of the original A matrix that we had as well. So let's move over to the next one. All right, now that we're at the next one, we can see that there are even more elements missing. We see that we have these two little triangles of zeros here, and we do have a lot more elements on this side of where our original identity matrix was. Now there's a lot more elements that look a lot less like the identity matrix. And then if we look on the left, we can see that there is some kind of semblance. We can see where we are getting the essence of the identity matrix almost. And this matrix is actually produced from these two row operations, which is literally just row 1 being added to row 2 and row 3. And then here we see that as we have this one, if we just divide this row by 2 and we multiply this row by a negative 1, we get the identity matrix on the left and A's inverse on the right. And I know what you might be thinking. How do we even know that this is A inverse? You could just be telling me things. You could be making this up. It's math. We can math it out, but what makes it true? I'll show you. All right, so I'm here to convince you. We have here that A inverse is going to equal to A augmented with the identity. And once we do some row operations and we flip these bad boys around, we're going to get A inverse, all right? So here we have, from our previous row operations and whatnot, we have the identity matrix on here. We have A inverse, supposedly. But let's see why. A inverse times its original matrix A should give you the identity, right? So what happens when we take A and we multiply it times this inverse? Big question mark, right, buddy? So we're going to grab our TI-84 plus CE calculator, and we're going to do this, all right? We're going to hit second matrix, A, 3 by 3 matrix. 1, 2, 1, 1, 0, 1, 1, 2, 0. Okay. And now, matrix. Negative 1. Okay. Seems about right. All right. Now let's multiply these. Matrix multiplication. And we get the identity. All right? We get the identity. We get the identity. As you can see clearly, A times B equals 1, 1, 1 across the diagonal. So here we have an invertible matrix. And why does it matter? Well, we know so much about invertible matrices. But you know what? I want to get out of this lab coat, so I'll see you outside. There are so many real-world applications with matrices, let alone invertible matrices. One of the ones that I'd like to highlight is actually image processing. I'm actually a computer scientist. I'm taking CSE 107, and we rely heavily on matrices. And when we are using these matrices, they have to be invertible. They have to be images that we can manipulate in a way that would allow us to change the grayscale, change any colors, change visibility, make it clear or easy or clearer or more difficult to see. But yeah, there's invertible matrices. I hope you really like this video. I'd really like to shout out to everyone who helped me with light, my roommates. Yeah! I'd like to thank everyone for their help. It was a lot of fun making this video, and I'm excited to make the next one. Thank you!